Welcome to my 7th video covering enemy AI inside of the 3rd chapter for my game design project making Zelda in Unity, well, Zelda knockoff in Unity. And so this one, like I said, we're going to take a look at enemy AI. So that means the enemy is going to do something more interesting than running straight at the player like this. We probably won't get to attacking in this video, but we will get into it actually having like an aggro radius and a few other important features. Let me knock its speed down a little bit here. I felt like it's 3 is surprisingly fast for that slime. So I'm dropping it to 2.5. But let's go to enemy and let's add a few more variables pertaining to the AI stuff that it's going to need to have. So, I kind of feel like inside of, we'll put it inside of AI stuff. We are going to need a public variable called aggro radius. And this is going to be how far away the monster will decide to start chasing the player from. Forgot the data type. Needs to be a float. And we can put a tooltip on it. And so that's the distance where the monster will switch from from just standing around to chasing the player. Well, I suppose we probably, well, we can add that later. We got the aggro radius. We are going to need, we got a lot of the movement stuff already. I think I'll put it in here as well. It's more of an attacking thing. Public Boolean prefer ranged, because that's going to affect the AI a little bit. So basically, does the monster want to stop moving towards the player once they're in range of their own ranged attack? So if it's a archer type of character, if it can start shooting the player, does it stop moving? In this case, I'm going to default it to false. Most of them just want to kind of just rush the player. Additional movement things. I'm going to build in the capacity for it to have waypoints. So let's add a patrol speed modifier. How fast does this thing move when it's in its patrol state? We will add the capacity for it to have a waypoints. And we'll make this protected. And which current waypoint it is currently at. And we could calculate this so it can figure out which one is it closest to, or we can just always have it default to the start of the list. I think it might be more intelligent for us to just calculate which one it is closest to. And so that looks like that is good for the movement. Now under AI, we are going to need to add a few more things here, such as I think we need actually the enumerator for the AI states. So let's just make that here. So public enum AI state. We're going to have the 0th state is idle. And that is just... Then the next state will be a chase state. A chase state is when the player enters aggro radius, follow the player. The next state will be a patrol state. And so it'll patrol, move around, and do things. Actually, I should probably make patrol the second state. Then there's super aggro. Super aggro is the state when it hits the monster, and the monster will find the player no matter where they're at. And that's all the states that we really need for now. So let's take this comma off there. So those are my AI states. Now let's set up a default state here. So it's going to be a public AI state called default states. And I think we can just set it to AI state.idle. So we'll leave it to be idle unless the programmer specifies otherwise. So of the states, idle means it will sit around, patrol means it'll go between waypoints, and super aggro means it will go straight to wherever the player is at, and then chase the player, which will then return back to an idle state if the player goes too far away. We need a protected AI state. We'll just call this state. That's just the current state that the thing is in. Reorder it just to be a little bit easier to follow here. And I think that's all we're going to need variable-wise. So we did add quite a few. So you can tell from the yellow parts here what I added and what I changed. So if you need to pause the video to grab this, now would be a good time to do that. So let's go update my my gizmos with the aggro radius now, so that we can get a good visual of where this monster wants to engage the player at. So we're going to draw it in green. Gizmos.color equals color.green. And we're going to gizmos.draw wire sphere at its current position, transform.position, to be the size of aggro radius. So we can see where is this monster going to start chasing the player from. And so with that, we are ready to start actually writing the core of this, which is going to be the actual AI and where it picks to do things. So I'm going to minimize move, but before I do, this can be deleted. This temporary code to be removed later, it's going to be done. That'll be handled inside of AI state. So I guess in front of move here, let's add protected update, capital I update AI. And this is, it's type void. And this is going to be the state where we update the AI and what it wants to do. Although I do think I need to quickly, inside of start, set its current state to the default state. So whatever we picked from that drop down menu, it tells it what state to use right away. All right. So let's start by just clearing the move modifier, because I'm going to use the move modifier in here. So if if the monster is idle, then let's think about what it wants to do. So the state idle is a default state. It wants to exit to super aggro and chase, and the purpose is to stay at the start location until player enters aggro radius. And or return to its home position. So, like, if it was chasing the player, then the player got too far away, it wants to return back to its home position. So this is where we're going to set target location equal to home position. Because if it is idle, the monster wants to go back to its home. So update target location. And then move modifier, we're going to set it to like 1.2. So the monster like kind of runs, air quotes runs, back to its home position so that it makes it harder for the player to kite the monster, like dancing within its aggro range. So it wants to get back to its home quicker. Now we're going to search for players. And this is actually very similar to that move thing we did. So we do a collider 2D called thing list. Could maybe call it things. Let's just call it things. Equals physics 2D overlap circle all from its transform dot position, and size is aggro radius. So this is going to get all the colliders within the circle of its aggro radius. And so we're going to go through each one for each. Collider 2D called item inside of things. If item.gameObject.compareTag, if the tag indicates that this is a player, then the monster now has its target. So what we're doing here is it searches for the player. And it's going to set its state to chase, so it will leave idle state behind. So let's put so if we're done with the idle, then this is end update AI. So after this, we're going to need an else if the state is AI state dot patrol. So this is one of the other kind of default states that it could be in. It's a possible default state. It exits to super aggro and chase, purpose, move between the waypoint list until the player enters the aggro radius. So that we're going to now write the purpose for this patrol method. I guess let me mark the end of this. End if AI state dot patrol. Trying to be very organized with the comments here, so it's easy to, because this does get kind of long, and I do want it to be kind of easy to follow along. So so if there are waypoints, so if waypoint list is not equal to null, and waypoint list dot length is greater than 0. So if there are waypoints in the list at all, then we will do this. Let's just throw an else right here. Otherwise, the developer didn't properly set this up, and we're just going to kick it back to the idle state. So if there was nothing inside that waypoint list, go to idle. But if there were things, we want to update the target location to be the waypoint. So we'll say target location equals waypoint list current waypoint dot position. We might need to think about what this current waypoint value is going to be, and so we might want to, inside of start, add some code to figure out which waypoint we're closest to, and then set the current waypoint to that one. Make it easier on the developer to set these things up. Or we can just make the waypoint public and it'll figure it out from there. So, I lost my train of thought here. It updates the target location to be the waypoint in the list. We're going to change the move modifier to be the patrol speed modifier. And that's so that the monster could move slower, maybe a little bit faster. If it's patrolling, I feel like it's not going to be going at full speed. That's why I set the default to be like 0.5. Now we need to calculate the distance to the waypoint. And that's going to be, we're going to calculate target location and my current transform. So then if that distance is less than 0.01, we can always play around with that. We're going to advance down the list of waypoints. So we'll say current waypoint equals current waypoint plus 1 modulus, where's the modulus key? Modulus the waypoint list length. So that's just a really clever way to add one to the list, and if we have exceeded the length of the list, go back to 0. So that's a pretty slick way just to increment by 1 and never go out of bounds on a list. So it kind of loops through the list infinitely. And then body.velocity equals vector2.0. So it stops the motion just so it doesn't like spin around the waypoint. When it hits that waypoint, it stops moving, and then it will go towards the next one. So that is our patrol state. However, I think we still need to grab this search for players, because we still want the monster to still do that same searching inside of patrol. So I'm going to put it right here after this else. So it's going to still search for players even though it's moving around. All right, so that is the patrol state with comments. So now for the part where the monster is going to chase the player, which is an interesting state. So right after this patrol state, we're going to add another else if state equals AI state dot chase, and target is not equal to null. And so basically meaning there's a target. Because if for some reason the player, let's say, is deleted or dies or something, then this is going to break, and we'd need to not be trying to update my position to be the target's position. So this is kind of protecting, and it will kick us out of chase should the player die. So move modifier is going to be 1 for this because we want the monster to move its normal speed. Now we're going to calculate the distance to the target, which is kind of different than the distances we've been doing before. We've been doing target location. This time we're actually calculating it to the target. Target.position, comma, transform.position. I guess I should put my little header here. So this is the state of chase. We'll put purpose. There we go. So here's our chase for the state of chasing. We'll come on here, and if AI state dot chase. So we calculate the distance to the player, and this is where we need to figure out, is the player still within my aggro range, or did the player leave? So if distance is greater than aggro radius times 1.2, so this is going to be the condition if the player has left aggro. Condition, the target is outside of aggro range plus 20%. So that way, the monster, once it starts chasing the player, it will chase it for 20% further than what it would have normally took to detect it. That prevents the player from dancing the aggro range and like getting the monster to chase you, then go back and chase them, go back. It makes it harder to do that. And if so, go back to idle. So state will be default state, and target will be set to null. So we clear out the target. Else, I think with all the RGB on my keyboard, I'd be able to actually see my keys better. So the condition is the target is within aggro range plus 20. Move towards the player. So that it wants to move towards the player or stay at range distance. So if it prefers range, so if the monster wants to prefer range, then if the distance is greater than or equal to its, oh, we haven't added that yet. Let's go up here to attacking and add a public float ranged attack range. And I'm going to set that to 0 because if a monster is going to have a ranged attack, we're going to set it to something else. And I guess, why not? Let's add it to my list of draw gizmos. We'll draw this one in yellow. So we'll do ranged attack range as a yellow circle. All right, so returning back to this chase, if distance is greater than ranged attack range, basically meaning it's not able to attack the player yet, the target location is going to be the target dot position. So the monster is not close enough to shoot at it, so it needs to get closer. Otherwise, drop these curly braces. Otherwise, the target location will actually be where it is, transform.position. So So that's kind of what's going on here. If it's out of range, if the distance to the target's greater than my range attack range, chase the player more. Otherwise, I'm within range and I want to just go toward and stay where I'm at. So this is prefer range. Otherwise, so if it prefers the melee, well, then it's just going to do this bottom case. It just wants to go after the player. Oops, we want target dot position. So, this is if the target's still within its range. If it prefers ranged, it makes a decision based on if it's in shooting range. Otherwise, if it prefers melee, it's just going to go straight at the player. And the slime is going to be a melee monster, so it's going to choose this other one. But we will add an enemy that is a ranged enemy, and it will prefer to stay at ranged. One more if statement. So the AI state would be super aggro, and target is not equal to null. So that's going to add another thing we're going to need to do is like if the developer sets super aggro as its default state, it's probably going to need to search for a player during start. We'll add that later. So if this is the case, and actually no, we'll just throw one final else here in. So if none of those states are applicable, just kick it to the idle state. So I guess then that would be the case, like if it was chasing and then the player died, it'll just go back to idle. So if it's super aggro, then move modifier will still be 1. So super aggro usually gets set if the monster gets hit by a ranged attack, in which case it wants to find the player that just hit it. So move modifier is 1. Target location is going to be the target dot position. And then we're going to calculate the distance to it. So then we're going to check the distance. If it's within the normal aggro range, then it's just going to go to a normal chase state, and it's no longer stay in super aggro, which means you could run away from it at that point. So we're going to calculate the distance to target location and transform dot position. And then if distance is less than the aggro radius, then so we'll switch to chase mode. And so state will just be AI state dot chase. So it'll go back to the normal ranged behavior and all that, so we don't have to duplicate that behavior here. And so that will actually kind of conclude most of that piece. So that's a lot of coding. At this point, you may want to pause the video to check. So I'm going to go back through this again. So this is the idle state. This is the patrol state. This is that's the chase state right here. And this is the super aggro state right here. So maybe rewind and catch those if you didn't get some, or just get the posted code and double check. So I hit save on all of that. That is a lot for the AI to do, but let's get working on it. There's a few things that I do remember it needs to do. Under being hit, one of the issues with the monster taking damage is we need to see if a player did that. And so if the monster gets hit by something, well, let's put that, I guess, back towards the end here. So if the monster got hit, we want it to enter the super aggro state. And we're going to actually pull this code here that we used for searching for the players. I'm just going to copy that. I'm going to close out. And going back to my hit method, instead of using just aggro radius like that, we could just do like aggro radius times really high, times maybe 10, so that it should be guaranteed to find a player almost anywhere. And if it finds that player, instead of going to chase, we want to go to super aggro instead, so that it will go and hunt down that player regardless of the range that this occurred at. Additionally, let's kind of grab this again real quick. We did... Ooh. I wonder why that's bad. Oh. I have one extra curly brace, I think. Okay, then let's go and inside of start, So if we chose to start it in super aggro, we should search for a player. So if default state is equal to AI state dot super aggro, then let's just throw that into this start menu here. And then what's going to happen is kind of an interesting thing here, that the AI will actually get into kind of an interesting loop, because if its default state is super aggro, it's going to search for a player. It's going to use 10 times its normal aggro radius to find a player. But inside of update AI, once it goes into chase, it'll try to get the player. But if the player eludes the monster, it goes back to its default state, which will be super aggro. And then we actually kind of run into it going back to idle, I think, because it's going to be super aggro without a target. Maybe we should just throw one extra one on here. So if it's in super aggro state and target is null, I guess we could take that out of this here. Let's just move it into that AI thing. So if the state is super aggro and there is no target, then search for a player and update that target. If target is equal to null after we've looked for it, then just go back to idle. So I guess if all the players are gone, or if it's just too far away, maybe we even need to bump this up. Instead of 10, let's just go to like 100, so that it will search anywhere on the map for that player. And if it still can't find a player, then it will give up and go back to being idle. So this thing will try to find players, but otherwise it'll just go back to being idle. And so going back to here, the last thing we would really need to worry about is updating this current waypoint. So that actually is going to be if default states is going to be AI state.patrol, and waypoint list is not null, and waypoint list is .length is greater than 0. So if it's in the patrol state, we need to see which should be our initial waypoint. And so we're just going to do a find minimum algorithm here. So we'll have float min distance. So from this thing's, from the 0th item's position to my position, we'll assume that is the min distance. And we'll assume that. And so we'll just go through the entire list. Kind of makes me wonder if there's a built-in thing inside of Unity to do this. But if waypoints list at I, I guess we need to do distance. If vector2 distance of waypoint list I dot position comma target, not target dot position, transform dot position. If that is less than the already established minimum distance, then min distance is going to be set equal to that. And min location is going to be updated. And then by the end of this loop, we should know the minimum location, so we'll set the current waypoint to min location. Well, that needs to be an integer. So we're just going through and doing a minimum distance algorithm of all the things in there. All right, so that should establish all of that. So let's go test this, and we should actually have a functional enemy now. It's not going to attack yet. It's going to have some chunky compiling to do here. And what we'll notice is you can see now these blobs have these circles. So this one right here is actually going to start in aggro range of me, so maybe let's kind of play around with some positions here. Remember that if you need to move the player's initial location, that's actually handled inside that scriptable object for player start position, where we have initial spawning position. So where is my player in the hierarchy? There it is. So let's move player a little bit away from all that. So let's put the player right here. So that looks like, let's drop this to -7, -3. So we'll have to update that player start position to -7, -3. And all these blobs now have more things inside of their script. Waypoint list is going to start as 0 for empty. The main thing is they now have an idle state of idle. If we were to give it an attack radius, you can see that that's going to show up now, but blobs have an attack radius of 0 because they're going to be melee. And when we hit play, that blob's just going to stand there because it's idle. But if I walk within its radius, it's going to... Oh, I didn't call the method to do any of this. Kind of important. Inside of update is where we need to call this. So just if it's not stunned, we're going to call update AI. So now it should do its thing. So when I walk into this circle, it will begin chasing me. If I manage to get out of the circle, oh, I didn't get out of the circle far enough. Let's go get these ones aggroed. So if I get far enough away, it goes back to its original location. You can see it eventually does get back there. If I shoot one of them, you can see that caused it to enter super aggro, and now it wants to chase the player. That should be true of this explosion as well. It hit it, now it's in super aggro to chase me, it's in regular aggro, and if I can get away from it, it goes back to where it was. So the last thing to do is just to show that these things can also patrol. So let's take this blob right here. Let's go and make him a patrolling type. So default state, let's switch that to patrol. And then let's just set this one to super aggro for the sake of argument. So if it's super aggro, it should chase the player. This one will go back to idle because there's no waypoints. And that one started at super aggro, and it's going to really stop at nothing until it gets to the player. But the patroller doesn't have any waypoints, so let's go give it some waypoints real quick. Waypoints are really easy to make. You just create an empty game object. We can call it waypoint 1. And I recommend giving it like some kind of dot so that we can actually see it. See, my cat likes waypoints too. And we'll put this waypoint here, and then we'll duplicate it. Waypoint 1, 1. Let's call this waypoint 2. And we'll put that over here. And so inside of orange blob, we will want to go to waypoint list and tell it, we can hit the plus sign to add some new entries, and we can drag and drop the waypoints into the waypoint list. And so it's actually closer to this second waypoint, so it's going to go to that one first because of that calculation that we were doing. It wants to go here, and then it'll go there, then it'll go back, and it'll go back and forth between those two waypoints. Oh, it got bumped by the super aggro one. Let's turn off super aggro. And so this one should just go back and forth between its two waypoints. And judging from this range issue, you can see that it's like overshooting it a little bit. Oh, we got an error. Oh, this typo inside of line, inside of this starts method. This needed to have been transformed out of position. I don't know why I didn't do that. Okay, so that'll fix that. Oh yeah, it was overshooting the waypoint a little bit. So one of the things that I could probably do is make this distance of considering that it's at the waypoint a little bit more, I guess, generous. So let's just go to distance is less than 0.1. And so we'll rerun this. And now it's hitting those waypoints a lot better. But the move modifier, I actually don't think I'm factoring that into its movement. So let's go check that. So inside of move, where we're calculating the move speed here, the maximum magnitude of the move speed, we probably should do move speed times move modifier so that it can cap it at that waypoint speed. And so that will then keep the monster from going too fast. And so now it has its slower patrol speed, but then when I get close to it, it's going to go to its normal speed as it chases me. And so we will stop here. Kind of a chunky video here, one of our longest ones. And we will then pick up with getting the blobs to actually attack the player. And then from there, we'll add a ranged enemy. And then we'll be pretty much done with the enemy stuff. We'll add the ability to prevent them from respawning. But that's what we got. And so we got waypoints working, we've got blobs working. You can name these waypoints slightly more interesting things. I need to actually probably fix that Z position. That could have probably also been part of it as well. Actually, it wouldn't have been because the waypoint 2 dot distance would ignore the Z values. But anyway, you should make sure that that's 0. So we are finished with this. Enjoy the enemy AI, and now you can actually start kind of planning out some interesting encounters with these. And then we'll do some attacking in the next video. So thank you for watching.